Hi, I'm Paul. We're doing Leetcode must know interview questions. Today's challenge is evaluate reverse Polish notation. Okay, what is reverse Polish notation? Do they have some examples down here? Um, Not really. Well, I mean, reverse Polish notation is the operands come first and then the operator. So 2 plus 1 would appear as 2, 1 plus. They do have some examples here. So 2 plus 1 times 3. How would that look in reverse Polish notation? 2, 1 plus. And then the 3, and then the multiplication operator. We'll look at that a little bit more. But anyway, you are given an array of strings called tokens that represents an arithmetic expression in reverse Polish notation. Evaluate the expression, return an integer that represents the value of the expression. All right, well, note that valid operators are plus, minus, multiplication, and division. Each operand may be an integer or another expression. I'm not certain what that means. I'm not certain what that means. I'm assuming that each token that comes in is going to be either an integer or an arithmetic operator. The division between two integers always truncates towards 0. There will not be any division by 0. Input represents a valid arithmetic expression in reverse Polish notation. The answer in all the intermediate calculations can be represented in a 32-bit integer. Okay, so a stack is a perfect data structure to evaluate reverse Polish notation. What we're going to do is we are going to access all the elements in the array. If the element is not an arithmetic operator, we push it on the stack. So example 1 here, we'll push 2, push 1, and then we get an arithmetic operator. Plus, if we get an arithmetic operator, pop 2 elements off the stack, in this case 2 and 1, apply the arithmetic operator. We'll get 3 and push it back on the stack. So now we have 3 on the stack. 3, we get the next token, that's a 3, push it, and then we get an arithmetic operator to multiplication. 3 times 3 is 9. Okay, example 3 is a little bit too much to work through. I mean, we can look at one more here. We're going to get 4, we're going to get 13, we're going to get 5, we're going to push all of those on the stack. We're going to get an arithmetic operator, division. Pop 2 elements off the stack, 13 divided by 5, it's integer division. So the result is 2, push the 2 back on the stack. Then we get another arithmetic operator, plus. What is on the stack now? 2 and 4. We pop those, add them, and we get 6. So if we can just kind of keep things straight here, this is, what is this rated as? Medium? It's pretty easy, really. Tokens length will be up to 10 to the 4th, 10,000. Tokens I is either an operator or an integer. Okay, good. So let's see. Why don't we use a, whoops, not down there. Why don't we use a stack? The input array consists of strings, some of which we're going to have to convert to integers, but stack string stack equals new stack. All right, int. Let me think for a second. Okay, we're going to need a couple of integers to hold integers that we pop off the stack. So let's call those x and y. we are going to need something called result. That needs to be a string because we need to push it back on the stack. If we push it back on the stack, it's got to be a string. If we're going to do math with it, it's got to be an int. String result equals, let's go ahead and initialize it. I don't know if Java is going to complain if we don't initialize it. Value. Yeah, we need something called value. That is going to be the result of arithmetic operators. I'm sorry, arithmetic operations. And we're going to need, I'm not sure we need anything else. I'm not sure we actually need to initialize result, but anyway, let's see what can happen here. Let's try and iterate through the array and see what comes up. For int I equals 0, I is less than tokens dot length. Let me move this over. Okay. If tokens, I is not equal to any, well, I still spelled it wrong. Okay. I just thought of something here. I mean, I was going to say, if tokens I is not equal plus and tokens I is not equal minus, all of the operators, but maybe there's a better way to do this or a simpler way to do this. String operators equals plus minus multiplication division. Is that going to work like that? Or is it going to take it as an escape character? I guess we'll find out. So now we could say if operators contains tokens I. If operators contains tokens I, actually that's not what I want. What I want is if not operators contains tokens I, then stack dot push tokens I. And continue. Just go back and get another token because yeah, we're going to push that. We're going to get the next token. If what we get is in fact an operator, then we need a switch statement on that. So we can do a switch on tokens I. Case. What if it's a, case? What if it is a plus? What if it's a plus sign? Okay. Let's do this. X equals integer dot parse int stack dot pop. All right, pop the first element, convert it to an integer. Do the same thing with the second element. All right, value equals x plus y, right? And then result we defined as a string because we've got to push it back on the stack. So result equals empty string plus value and push it. Stack push result and break. All right. Now I got to think about something. Well, all right. The other case statements are going to be very much like this one. All right, in this case, let's just do the minus. You know what? I'm thinking I'm just repeating the same thing over and over here. Why don't we do this? Why don't we take the x, y pop, because we have to do that every time, and put it here. All right, good. Case plus value equals x plus y, return. All right, good. Same thing here, the x, y. The value for the minus, because we popped the x first. So x is the top element. Y, I mean, what we're going to have in the stack, well, the operator, I guess what I'm trying to say is really this should be y minus x. Result equals and plus value, stack, push, break. I wonder if we could move some of this other stuff to the end too. I'm going to, well, let's just go ahead and do it first and then consider that. All right, next we have multiplication. All right. We've popped the values. Let's just say x times y. Result is empty string plus value, and we push it. Okay? One more. Case could be a division. Now, if it's division, we need y divided by x because of the order in which we popped them. Push that, push that. Really, it shouldn't be anything else. But I guess we could put this default. Continue. Yeah, that would work. Are we still in the for loop? Because a lot of this is the same. A lot of this is the same. Like these 3 lines, these are the same. So I don't think we need them in every case statement. So let's take that out. Oh gosh, no, we needed the break. We needed the break though. All right, hang on. All right. Let me put that there. Let me take the break and put it back. Here, 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 and here. Break out of it and then all right, result, stack, push. All right, that's good. After the for loop, what we're going to want is to return whatever is on the stack, which should be the result. Return integer dot parse int stack dot pop. Okay. That looks like it's worth a try. Let's try running that. Compile error. Oh, what is that? Line 9? Oh, my mistake. Semicolon I plus plus. And then line 10. If operator contains, okay, forgot a parentheses. Okay, try it again. Accepted. All right. Pull this over a little bit and submit it. Okay. Not bad. Looks like everybody's kind of in the same place on this. There's not really a lot of ways to do this, I don't think. Reverse Polish notation. Just define a stack. Push the numbers. When you encounter an operator, pop a couple of numbers, apply the operator, push it back. Eventually, you'll get a result. Memory use is very good. I'm kind of curious about the memory use. Okay, so that's it. Hope you enjoyed it. Let's see. Feel free to like, subscribe, comment, and see you next time.